Okay, so this topic, this question covers the topic of mensuration, specifically cylinder, cone, and also in the second part, you will see the same shape, but there will be similar triangle, the area and volume of similar triangle involved. Okay, so we'll do it part by part. Okay, some people will get stuck in part A if they fail to read certain information. Okay, so take some time to read carefully. So there is a sealed container, that means it's a closed container, for connecting a cylinder and a cone. So at this point, right, what you can do is you might want to write down the volume. Okay, if you want to process the information, you might write down the volume. Okay, if you want, you can write down the surface area, but I think this part doesn't involve surface area. Okay, and then after that, they describe to you the dimension of the cylinder and the dimension of the cone. So the height dimension of the cone is not given. Okay, however, they actually share the same diameter. Okay, now the key thing is this word. The container is half filled with water. And the water fills exactly the cylinder. So from these two sentences, you got to understand that the volume of the cylinder is actually equal to the volume of the cone. So the container is half filled with water. That means when the water is here, the container is half filled. And when it is half filled, it's just filled up the cylinder. So from here, you must have the idea that they actually got the same volume. Otherwise, you will get stuck. Okay, so if actually you get this idea, then that is just executing the formula. Okay, you can execute the formula. Okay, you can try to find the volume of the cylinder first, because the dimension is given to you. So you can try to find the volume of the cylinder, which is the volume of the water. So my suggestion is leave it in terms of pi, so you don't have to deal with long number. So essentially, this is also the volume of the cone. So that means, right, 1/3 pi r square times height should be equal to the same volume. So one of the things about keeping it in terms of pi is at this stage you can cancel. And then from there, I'm quite sure you can work out the value of H. So the critical part of 26A will be, you must realize that the volume of the cylinder is actually equal to the volume of the cone, or else there's no way that you can find out. Okay, in part B, it's a second container. That means it's not the same one. It's a second one. And if you look at the second one, it is also the same shape. It's also cylinder and cone. However, the dimension is different. Okay, so you must check out the dimension. Okay, so the dimensions are given. Okay, but it's a different container already. Okay, the container is still half full. Okay, this amount is half the volume. It's half full with water. So that's the question. Okay, so it's different from the previous one. So will you be able to find out this amount of water? Yes, you can find out this amount of water because you will be able to find out the volume of the cone, and you will be able to find out the volume of the cylinder. So if you add the two of them up, you will get the total volume. And then the amount of water is half of the total volume. Okay. So after that, right, our job is to find the depth of the empty space. to find the depth of the empty space, you need to use the idea of similar volume. Okay, where is the similarity? Right, is here. You need to use the idea of similar volume. Okay, so in a way, right, I will need the height. Okay, I will need the height. So I already got the ratio of the height. So this is D, and the long one is 90. Okay, so I already need the, I already have the ratio of the height. So I am actually using this formula. So I'm trying to use this formula in order to find the value of D. Okay, however, if I want to use this formula, I will need the volume. Okay, so which volume am I looking for? I'm looking for the volume of the empty space. So the empty space here, okay, I'm going to make it into V1. And then this whole space here, I'm going to use it as a V2. So that is the bigger picture for the whole question. Okay, so my approach to finding D is to use this formula, the volume ratio formula. So I will need the ratio of the height, which is there already. So I should work out my way to find the separate volume of the empty space and volume of the cone, which can be found. Okay, so it's just that there is a lot of steps. So in a lot of steps, right, you need to try to leave your answer in terms of pi. Okay, so like I say, right, I should start off by finding the total volume so I can find the volume of the water. Okay, so you can do very step by step. Okay, so volume of cylinder. Okay, I will not show the working. Okay, because I already show you the general approach. So I'll work out my cylinder. So my cylinder ends up to be this. Okay, I will work out the cone. Okay, you apply the formula, you will be able to apply the formula because all the dimensions are given. Okay, so which means, right, the total volume, you will be able to get the total volume. You add them up, and you will be able to find the amount of water. So what is the amount of water? So you need to label your working very carefully. Okay, ultimately, don't lose focus. You are supposed to find the volume, V1, which is the volume of the empty space. And you need to find the volume of the bigger cone. Okay, so from here, the water will be half of it. Okay, so I need to find out what is this amount of water first, because I need this amount of water to find the empty space. So from the water, I am going to subtract the water from the cylinder. I'm going to subtract the amount of water from the cylinder. I think it's the other way around. Okay, so it's the amount of water here is 2750 pi. If I want to find out what is the amount of water in the cone, then I should minus away the cylinder. So I take the full water, minus away the cylinder. So now I can find the volume of the empty space. The volume of the empty space will be the cone minus away the water in the cone. I think I make a mistake here. This one should be 200. 250. So essentially, this is my V1. Then the cone is actually my V2. So now I can form my formula. So V1 over V2, L1 over L2 cube. My V1 is the empty space. My V2 is the cone. Okay, the ratio will be D over 90 cube. So from here, you work out. I'm quite sure you know how to work out from here. So round your answer to 3 SF. Okay, so there's a lot of steps, but ultimately, right, you are using the volume ratio formula. So just keep everything in terms of pi, otherwise you will waste a lot of time dealing with a lot of decimal. Okay, so this is the question on mensuration and volume ratio.